7.1, we're chapter 7. We're kind of moving in away from chapter 6, where we're doing a lot with rational expressions, square roots, third roots, fourth roots, that kind of thing. And chapter 7, we're moving away from that and going more to exponential equations. Okay, now, and we're talking about exponential equations, exponential functions. We're going to set this up and show you, the difference of the two, because, again, there's really only one difference between an equation and a function. All right, now here's the biggest difference when we're talking about exponential equations. That everything we've done up to now, the x was the base. We did x squared, we did square root of x, we did all x to the third power, all these other things. The difference for exponential equations or exponential functions is now instead of x being in the base, x is in the exponent. And that's the biggest difference that we're looking at for chapter 7. And that is the big difference that we're looking at now. So instead of x being the base, instead of being x squared, now it's going to be 2 to the x power. So we're kind of reversing everything around when we're going through these. If you talk about a function, if you remember, the only thing we did different between equations and functions was equations, instead of having y equal, for a function you have f of x equals. And you have b to some power x in this case. Well, because there's some things that grow exponentially, like bacteria, that you have to account for the growth that it has on that part. And there's some things that just kind of, now it doesn't happen forever, but you have a short-term part of it where it's going to grow exponentially, and then you've got to kind of figure out what you're going to do to combat that. So there's different things. Now, if you want just how this is going to look, like with the numbers here, an exponential equation could look something like this. It could be y to the 3x power. And if it's an exponential function, you're still going to have the f of x. And it may be, in this case, it could be that it's maybe 1/2 to the x power. Okay, but again, if we're talking about exponential equations, the big thing is that the x is always in the exponent. And that's a big difference from what we did before. If we reverse this thing around, everything we've done to this point, this would have been x to the third power. Well, these are going to be two totally different graphs when we start looking at them, because if x is the base, it's got a certain way it reacts. If x is in the exponent, it's got a different way that it's going to react to what we're doing there. So that's kind of the big change that we're looking at for this part. All right, so two big things. If you have exponential growth, the basic shape, the basic idea that you want to think about as far as the function goes is something like this. Again, if we think about, for this part of it, we're thinking about y equals b dx, so we're thinking about just an equation for this part. Yes? What was the question on the homework? And it was like a graph. Alright, so here's what we're doing. Here's what we're looking at. If we're doing exponential growth, the key thing is, if you're doing this one, your base has to be bigger than 1. So that's the key thing about exponential growth, is your base is bigger than 1. So back up here, we have this one. This would be an exponential growth if we're looking at this part of it. And the basic shape, no matter what it is, whether your base is 2 or 3 or 4 or 5, they all have one basic shape. And they all look something like that. Now, there is one thing they have in common, no matter what the base is. The one thing they have in common is that they're going to cross right here at the same point, and that's going to be at 0, 1. Now, if you may be saying, well, how can they all be at the same point? Well, think about this one, and kind of flash back to some of the basics we had with exponents a little while back. And I think we talked about this one. What happens if you do anything to the 0 power? It's 1, right? So whether it's 3 to the 0 power, that's 1. If it's 4 to the 0 power, that's 1. If it's 5 to the 0 power, that's 1. If it's any number to the 0 power, it's always going to be 1. So that's why this point's always at 0, 1. You can plug in 0 for x, and if you do, no matter what this number is, it's always going to give you 1. So that's going to be the one thing that they always have in common. All right, now, and here's the growth part of it. And really, you almost ignore the left side of the graph over here. So just ignore the left side of the graph because the growth part is really on the right-hand side. And if you're going to do exponential growth, you have to have something to start with. So this is where they tell you, all right, you're going to start with basically you're starting with one chunk of bacteria. You're starting with one fill in the blank that you're going to do, and then you're going to get the growth that goes from there. You have to have something to start with it before you get the growth and kind of go from there. You can't have something from nothing. You have to have something to start with. Okay, and on the flip side of it, exponential decay. Okay, so for exponential decay, your base is going to be less than 1. Now, here's the thing with the base, though. It has to have something in it, so it's got to be between 0 and 1. So your base has to be some number that's less than 1, but it has to be bigger than 0. Because, again, if it's 0, you don't have anything there. There's nothing that can happen if you have nothing. All right, and for decay, it's basically going to be the opposite. That instead of the right side of the graph getting bigger and bigger and bigger, the right side of the graph is going to keep getting smaller and smaller and smaller. So this is basically going to be just a flipped graph from what we had up here. Now, we're still going to cross at the same point. This is still at 0, 1. So exponential growth, that's what happens when you take bacteria, put it in the right conditions, and let it grow. It's just going to grow and grow and grow and grow. That's how they figured out all the medicine that we have today, most all the medicine we have today. Penicillin, it was an accidental discovery they made with bacteria that the bacteria would start eating some of the different things that they were working with. So all the stuff we've got today, your penicillin, the amoxicillin, almost all those antibiotics came from somebody working with germs in a bacteria in a petri dish. Exponential decay, this is your carbon-14 dating. That basically they're kind of saying, all right, again, if we worry about the left side of the graph, when you're alive, you have 100% of the carbon that's in your body. And as soon as anything starts to die, whether that's a plant or animal, whatever, you start to lose part of the carbon that's in your buildup. And this is that decline or that decay because you're going to start here at 100%. And once that organism dies, it starts to get rid of the carbon that's in the system. And so that's your decay. That you can somewhat predict, how this thing is going to decay and how much carbon you're going to have when you go through this thing. Okay, so now whether you do exponential growth or exponential decay, either one of these two, your domain. So get over there. Decay, your domain is going to be negative infinity to infinity. You can plug in any number you want to into either one of these two equations, and you're going to get an answer that you get off of it. And again, that's moving side to side. And if you look at it for the range, on either one of these two, what's the lowest number we're heading to on these two things right here? Either one of them. Getting close to 0, right? Because again, if it's an exponential decay, we're trying to chase this thing out and see. Now, again, there's always some part of carbon-14 that's in it, no matter how old it is. Maybe a very trace amount, but it's always there. So your range is you're going to have 0, and then you're going to have an infinite amount if you were doing exponential growth, because again, if you let it grow forever, it would just keep growing and growing and growing. Now again, based on conditions, it's not going to happen that way, but potentially you could let it go forever. Okay, now here's the one thing that we have for this one. For the range, this is going to change. This will change based on the function. So with the range, it's going to change based on the function when you add or subtract numbers with the x. Now, the domain is going to always be negative infinity to infinity. That part's not going to change. But the range, if we start adding and subtracting numbers to this expression up here to be the x, if we start adding a +2 or a -3 or something, then this is going to change this range because you're going to have to start adding and subtracting numbers to it. But in just the basics, if we don't do anything weird, we've just got b to the x power, and that's all it is. This domain range is always going to be the exact same answers. Now, when we start adding and subtracting to the x up here to this equation, then we're going to start changing the range when this goes a little bit to it. Okay. Now, just to make sure everybody kind of remembers, we're going to take a tiny step back for just a second. Just to make sure everybody knows exponent-wise what we're doing here. I know we've talked about it, but again, sometimes it's good just to stop and get it again just to make sure everybody kind of knows what's going on. Alright, and again, this is just kind of walking back to the zeros, especially the negatives on these. If you have 3 to the third power, what is 3 to the third power? 3 times 3 times 3, right? 27? Okay, what about 3 squared? 3 squared is 9, right? Of course, 3 to the first is 3. Now, here's kind of where we're going back to the 0 power. And I think we mentioned this one, but again, it never hurts because sometimes people didn't hear it the first time we talked about it. If you start with some expression you got with an exponent here, that if you take a power off of x up here on this power, you're going to take this thing and divide it by 3, right? Same thing on the flip side. If you start here with 3 squared and you go up to 3 to the third, you can take this answer and multiply by 3. So depending on which way you go, you're either going to multiply by 3 or divide by 3. And that's why that if you do 3 to the 0 power, you can take this answer and divide it by 3 to know that anything to the 0 power would be 1. So if you keep moving down a power, you keep dividing by 1. And that's where when we get to the negative power, if you have 3 to the negative 1, it's going to be the same thing. You're going to take this answer and keep dividing it by 3. If you take 1 divided by 3, we're just going to leave it in fraction form. It's just 1 over 3. Alright, you got 3 to the negative 2. Ooh, now this is a good question. We just got finished with the exponential. Y'all remember what we did in chapter 6 when we had the negative exponents? What did that really mean for the negative exponents? And to make it positive, what did we do with it? Or, you remember that we took that negative number and moved it to the denominator? Oh yeah, there you go. Got the reciprocal part of it. There we go. So if you've got a negative power, remember it's the same thing as 1 over 3 squared, but right now you know that 3 squared is 9. So that would just make it 1 over 9. And we'll do one more here. If you had 3 to the negative 3 power, that would be the same thing as 1 over 3 to the third. If you do 3 to the third, that's 1 over 27. Alright, now here's the one connection that hopefully you're seeing with this one. That if you have a positive exponent and a negative exponent, the only thing that's different about these two things is one's a whole number and one's a fraction. But you're going to use this exact same number here, you're just going to put it as 1 over that. So if it's 3 to the second or 3 to the negative second, it's the same answer, but just this one needs to be in fraction form. Same thing with the third power. They're the same numbers. They're both 27. This one's just a whole number. This one's just a fraction. And that's the kind of connection they want you to see. Same thing with the 3 to the first or 3 to the negative first power. It's the same number. It's just this one is 1 over that number. Okay. So that's the things you got to kind of think about when we're going through these with the negative exponents and all the parts and pieces of it. Okay. Now, what we're going to do is we're going to give you one graph where in some of the homework and even some of the tests, there may be one time where I'm going to ask you, here's 4 or 5 different values. You need to plug these in and make this graph just by plugging in numbers. Once we do it one time, we're going to let you kind of do a shortcut on the rest of them. so you can kind of get through these a little bit quicker. But that's kind of what you want to think about as we're moving through everything. With the negative exponents, it's the same answer as the positive exponents. We just need to make it 1 over that number. Okay. Now, and just make sure you've got this one memorized, because that's going to be kind of a big one. That 3 to the 0 power, anything to the 0 power is 1. That's kind of your main thing there. Okay, here's one where we're going to graph y equals 2 to the x power. And for this one problem, I'm going to make you do a little chart and plug in the numbers. And then after this one, we're not going to do that for the rest of them. Okay, so we're going to start with 3. So we're going to do y equals 2 to the 3rd power. Alright, so if you do 2 to the 3rd power, that's 2 times 2 times 2, that is 8. So as an ordered pair, that would be 3/8. Okay, and we're just going to walk this one down, and usually they'll give you specific numbers to plug in, so we'll kind of do this one the same way. So we're going to do 2 squared. Well, that's just 2 times 2, so that's 4. 2 to the 1st, well, we know that's just 2. And again, if we do 0 power, anything to the 0 power is 1. Okay, so when you're graphing some of these, they're going to have you fill in the blanks on this one where they're going to give you these specific values. And we're going to do a couple of negatives just to make sure everybody's good with a couple of negatives here. Alright, so we plug in -1. That's y equals 2 to the -1 power. Again, with a negative power, that just means it needs to be in the denominator, so that's 1 over 2 to the 1st power, which is still just 1 over 2 to the 1st, or it's just 1 over 2. Now, if you don't like this as a half, you can always go back and change it to a decimal. You can make it 0.5 if you want to. Or you can use a half. Either one of those two is okay there. Okay, if we do -2, that's y equals 2 to the -2 power. That just means it's 1 over 2 squared. And then you can do 2 times 2 and make it 1/4. And for that one, if you want to leave it in fraction form, you can. They should tell you whether they want the answer in fraction form or decimal form. So they'll kind of clarify which one you want there. Okay, now we haven't done any graph. This is basically just getting the numbers. So this would be where now you would take these numbers, these ordered pairs, and go back and put them on a graph so you can get the exact pinpoints. Because when we did this one back here, just flashing back for a second, when we did these two graphs, the only points we actually listed were these 2 points at 0, 1. This time they want more than just 1 point. They want you kind of just to give me a list of these. Now, the good news is you're not going to do these for all of them, but just the first couple ones are going to kind of get you settled in. Yeah. How do we know what? Oh, they'll give you a list. So like this list right here, they would have already had these numbers, and then you just go back and plug them in. All right, here we go. So let's graph this thing. Okay, so for the y values, we went up to 8, we went down close to 0, so really we just need to go from 8 to 0 here. The x's, we went from 3 back to -2, so that's the numbers we got to plug in. Okay, so if you start with 3, that point was at 3.8. That's up here at the top of the graph. Next point was at 2.4, so over to 4. Next graph was at 1.2. Next point was at 0.1. Now, and when you get, and here's the thing with the homework, when they do this, once you put in a couple of points over here, it's going to kind of automatically fill in your graph, or they'll give you a multiple choice where you fill in the graph. So, you know, it's going to be impossible to graph -1 and 0.5, because if you try to graph it, well, it's somewhere about here. Yeah. But you're not going to have to do this for every problem. They're going to let you take shortcuts after this. Okay, so if you take those 5 or 6 points they ask you to graph, there you go. That's what it should look like. And again, as long as that base is bigger than 1, which it was back up here, then it should always kind of follow that same thing. And this is where we go back here to this one. This one was bigger than 1. It's got that same basic shape right here. Okay. All right. Now here's where they're going to ask you a couple questions in the homework too. Well, most of these they're going to have multiple choice, and you're just going to have to go back and just, once you've plotted the numbers and done some things, you're just going to go back and pick the correct graph that's there. And to get that, you're going to need some specific points, and that way you can go back and see if these points are specifically on the graph or not. And one thing they're going to ask you to do on these is once you get finished, they're going to ask you to identify this one as either a growth or decay. And again, the main thing is if the right side's going up, it means it's got to be growth. And now, and in this case, if they ask you to, some cases they're going to ask you to find the y-intercept. This one, you've already got the y-intercept, because to find the y-intercept, it's where it crosses the y-axis. Well, that's right here. If they give you an equation, and they don't have the graph, because if it's on a graph, it's easy. You look on the y-axis, you tell me where it crosses, you got your y-intercept. Some of these are going to give you an equation, so they're going to ask you to find the y-intercept from an equation. So to find the y-intercept from an equation, just plug in x equals 0. Now, for this one, we didn't have to. Now, we kind of did both of them. We got the graph, but at the same time, we plugged in 0 right here. And when we plugged in 0, we got 1, so we knew the y-intercept was going to be at 0, 1. So sometimes they give you a graph, sometimes they give you an equation, and just know how to work back and forth between the two of them there. Okay, now again, they're gonna kind of build the graphs a little bit, so you won't have to get every single graph. You're not gonna have to do this. Some of them they're gonna give you multiple choice, and you just pick the graph once you kind of figured some things out of it. So you're not gonna have to spend hours graphing these when you're going through this part. Okay, so here's what we're going to do for these. With these, we're not going to ask you to graph these. We're just going to ask you to identify it as growth or decay and find the y-intercept. Okay, so for this one, first example, you've got y is equal to 0.95x. Again, this part should be the really easy part, because growth or decay, you look at the base. Bigger than 1 or less than 1? 0.95, that's less than 1, right? If it's less, that means it's decay. So there you go. Because in this case, your base is 0.95, well, that's less than 1. So if the base is less than 1, it's decay. If it's greater than 1, then it's growth. Okay, for the y-intercept, again, this is one where they're not going to give you a graph, they just give you the equation. Well, we said to get the y-intercept, you just have to plug in x equals 0. And if you do 0.95 to the 0 power, that's going to give you 1. So your y-intercept would be, they're probably going to make you do this in order pair. So if you plug in x for 0, you get 1 for the answer, so your y-intercept would be at 0, 1. Now, if people are thinking, well, you said that no matter what we do, if we plug in x for 0, we're always going to get 1. Yes, but they may have you add or subtract, multiply, divide some numbers around it. So you may get 1 to start with, but then you might have to multiply by 2 or divide by 3 or add 6 or something like that. So it may be that you might have to do some other things. So I'll show you this one. Alright, so for example 2, a little different look to it. We're going to do the same thing. You've got 0.5 times 3 to the x power. So there's your x in the exponent. In this case, the 3 is attached to the x, so your base would be 3. And if your base is 3, that means it's a growth. And for the y-intercept, plug in 0. Now, here's where you got to go back to 7th grade math. What's the first thing you do in order of operations? Parentheses, right? Now, you've got parentheses around 3, but there's nothing you can do for that part. The next thing you do is the exponents, right? So then you got to do 3 to the 0 power, which is 1, but it's 0.5 times that number. So then if you do 0.5 times 1, that would make it 0.5. So, yes, we plugged in 1 and it made the answer, or plugged in 0 made the answer 1, but because we had to multiply it by 0.5, that's going to change your y-intercept here. So now your y-intercept is going to be at 0 and 0.5. So, yes, you are going to get a 1 every time when you plug in the 0, but then you're going to have to add it, subtract it, multiply it, divide it. You're going to do something else to it sometime, so it may not automatically make the default answer out to be 1 for the y-intercept, because you may have to add, subtract some numbers to it. Alright, let's give you a couple more of these, just to make sure we got it. Alright, so this one, for example 3, let's go 2 plus 1/3 to the x power. Alright, same thing with this one. You've got 1/3 to the x power, and you got the 2 to add to it, but the main thing is it's whatever x is, it's in the exponent, so that means your base would be 1/3. And since the base is less than 1, that means it's going to be decay. And then for the y-intercept, plug in the 0. Now again, just because it's got the f of x in it doesn't really mean anything. You're just worried about this side. So it's 2 plus 1/3 of the 0 power. So this part is 1, but then it's 2 plus 1. That would be 3. So then your y-intercept would be at 0, 3. So when you start adding and subtracting or multiplying the base by something, that's going to change your y-intercept because you're going to have to move it around just a little bit. All right, one more of those, just to give you one little small different look here. Okay, so for example 4, let's do 3 times 4 to the x power, and this time they put the 4 to the x power in parentheses. Okay, even though it looks different, and again, it's not a big difference, but they just kind of move the parentheses around. It's still 4 to the x power, so your base is still 4, which means this one's going to be a growth. And y-intercept, same thing, just take that number, plug in the 0 power. But again, 4 to the 0 power is still 1. 3 times 1 is 3. So then your y-intercept would be at 0, 3. Okay, so that part hopefully should be pretty easy. Just find the base, whatever's attached to the x for the exponent. If that number is bigger than 1, it's growth. If that number is less than 1, it's a decay. And here's the one formula you have to kind of know that fits into all the different things we're going to do. And this one formula is the exponential growth or decay formula. And again, it's the same formula. If the base is bigger than 1, it makes it grow. If the base is less than 1, it's going to make it decay or shrink. So it's the same formula either way, no matter what you do here. Okay, so there's your one formula. It's A of t. And again, this is just the notation, so this is really not a big deal here. It's A times 1 plus r to the t power. Okay, now the A of t, basically that's just the amount. That's how much, if we're doing bacteria, that's how much bacteria we have after a week or 2 weeks or 3 weeks. If we're doing decay, this is how much carbon is left after 5 years, 10 years, 20 years, 100 years, 1,000 years, whatever it's going to be. So this is just the amount of bacteria or whatever it is you're looking for after so many periods. And again, the periods could be years, it could be weeks, it could be months or days or hours, depending on what you're going to do. The A variable, that's your initial amount. Now, you can even tie this in with money. If anybody's seen our national debt clock, now it's a little bit different. It's just running all the time. It's an exponential growth because we just owe so much money to so many people. It's growing all the time. We just owe more and more and more and more money. So that when you're that thing clicking all the time, that's an exponential growth because it's running all the time. Okay, the R is your rate as a decimal, so if it's 5%, you got to change that to a decimal, make it 0.05. And then T, that's just your time. Whether that's years, days, weeks, months, whatever, that's just how long we're going to do this thing. Alright, so here we go. Here's a question. It's a word problem, but you know, it's okay. You're going to have to kind of have word problems with these. Let's say you have $1,000 to invest. And let's say somebody's going to, you get an uncle or a grandmother or whatever, that somebody wants to give you some money. They're going to tell you, all right, here's $1,000, go save it so that when you get out of college, you got a little bit of spending money. So here's $1,000 to invest for 6 years. And let's say you get 5% interest rate from a bank to get it there. How much money do you have after 6 years? So here's a pre-graduation present that you'll have when you graduate from college in 6 years, because you're in high school now. So give you year or two to finish up. Okay, so we're going to take this thing and just plug it back in the formula up here. So the A, that's your initial amount. So that means our A is 1,000. The rate was 5%. But again, you cannot use percent. You got to change it to a decimal. And to do that, you've got to move it 2 places to the left to make it 0.05. And our time, well, that was our 6 years. So T equals 6. So the only one you have to do any adjustments to is your rate. Whatever rate they give to you, if you have 5%, your decimal's here, you have to move it over 2 places to the left every time. All right, and then we're going to take those 3 numbers, plug it into that formula, and just work this thing out. Okay, now the 6 in this case, that's the T you would plug in here, so your amount of 6 years later would equal the $1,000 times 1 plus 0.05 to the 6th power. Okay, so taking that one formula, plugging the numbers in, that's what it's going to look like. And this A of 6 on the left-hand side, you don't do anything with that left-hand side because it's just letting you know that the amount we're looking for is 6 years later. So this is just a notation. All the work's on the right-hand side. So that's 1.05 to the 6th power. All right, so if we do 1.05 to the 6th power, just check it real quick. Up here so y'all can see that real quick. 1.05. And again, there's your power button right here. Looks like the rooftop. Do that to the 6th power. And that is 1.340000956. Okay. Okay, now when you do these numbers on the calculator, because you're going to have a calculator for this one, don't round this number off. Leave it in there. Leave this whole 1.3400956. Leave all that in there, and then multiply it by 1,000. And once you do that, that's the number you got to round off. Since this is money, oh, sorry. Thank you. There we go. Well, that's okay, because I had 100 times 10, which is 1,000, right? Wow. There we go. Okay. So if you do that, you've got 1,340.
Please release all seniors to Gym 1 for the Veterans Day program.
And because of money, you got to round this off to 2 decimal places. If you do, it's 0.09, so we've got 9 cents, but you got to take that 5 and round it up. So that should be 1,340.10. All right.